Hi, Raylene. Boy, these trig identities, they can be really tricky until you start realizing there's some common tricks that you use all the time. I know I have the entire thing here, but I'm going to step you through this step by step. So when I look at the original equation, and I wrote it here out so it looks like the fraction that you're used to on your paper. When I look here, let me get it right. When I look here at this line, I see two fractions on the right, but only one on the left. So that tells me, even though I may not know where it takes me, then I want to make one fraction out of that right-hand side. So how do you do that? Even though it looks kind of weird, is that you're going to find a common denominator. And my common denominator is both of those denominators, 1 minus sine alpha and 1 plus sine alpha. So on the next line here, I just multiply each fraction by what it was missing in the denominator. So that first fraction needed a 1 plus sine alpha. So remember, you got to do top and bottom so you don't change the equation. And on the second one, I did 1 minus sine alpha over 1 minus sine alpha. Okay, so then the next step after you do that, just like with all fractions, you want to multiply out the tops. So I distributed the 3 to the 1, the 3 to the sine alpha, and that's how I got 3 plus 3 sine alpha. And on the other one, I multiplied it by 3 also. Notice I didn't multiply out the bottoms yet. I'm going to, but I'm just going to keep it like that on the bottom. Then the next step is, first of all, check it out. Check out the second part right here, how that became positive. It's because you have to distribute that minus sign to both things on top, and that would reverse it to plus. And then what I did there is I cancel out the 3's because they're opposites. Okay, so now I'm over here on the right-hand side of the page, and all I did is add the 3 sine alpha and the 3 sine alpha, and it gives me 6 sine alpha. Okay, so next, what I was doing, whenever I see a sine squared or a cosine squared, I always think about Pythagorean identities, because usually you can use one of those. So the typical one is that one, right? Sine squared plus cosine squared equals 1. But if you rearrange it and solve it so it matches 1 minus sine squared, you get that it equals cosine squared. Okay, and what I do when I'm first learning these is I would write out all the versions of sine squared plus cosine squared equals 1. So I've given you 2. The third one would be sine squared alpha is 1 minus cosine squared alpha. And that's a nice way to keep that all together so you don't have to rearrange every time you're looking at these. Okay, so I replaced the bottom of the right-hand fraction with the cosine squared alpha. So the good news is now I have one fraction, and at least I have cosines on the bottom here, right? So, okay, but I only want one cosine, not cosine squared. So what I decided to do is split it up. And that's what I did on this line. So I made it sine over cosine times 1 over cosine squared. 1 over cosine, excuse me. So that's the exact same thing as the one above it. And then I recognize sine over cosine is tangent. So I replaced that with tangent. And I did that because I saw on the left side it had a tangent. So that worked out great. And then to get to the last line, all I did is multiply 6 tangent alpha times 1 over cosine alpha, and I get it to match. So the big lesson here is when you start, you may not know how you're going to get to the end, but do some simple things. In this case, this is a classic example of trying to combine two fractions into one. Don't freak out that it's trig here. Just think about how you do it in regular algebra or arithmetic. Combining it and then looking for identities and things to replace along the way to match the other side. I hope this helped you, Raylene. Look me up if you're interested in more trigonometry help. I'd love to help. All right, good luck.